Okay, so everything is ready. I think we're just gonna wait for the student to come. It's 6:30 p.m. already. So far the parents didn't say any issues whether the kid could join the class or not, but the parent already confirmed to ask whether the link would be the same or not to join tonight class. So yeah, let's just wait for student to come. Maybe she will inform me later. Usually the student will come late because the kid is probably just coming back from the school or you know after accompanying her mother. Uh, he will probably late for like 5 to 10 minutes. So yeah, let's just wait for the student. Okay, the student is here. Let's start this. Hi, good evening, Widi. Hello, is there anybody there?
Yes, Kak Iqbal,
Ah,
tunggu sebentar ya, masih dinner.
oh ya, nggak apa-apa. Selesaikan dulu aja, Bu. Tidak
Paling
apa-apa
tiga
kok.
menit.
Iya, siap-siap.
Tunggu ya, Kak.
Ya,
Thank
Ibu.
you. Ini cara mereka ya.
Okay, I think it's ready. Hello, Edie. Good
Oh,
evening. Sorry, I don't mean to rush you for your dinner. Hopefully you don't mind. So what do you eat? Just
X and ayam suwir. Aduh, pati ko ano.
ah, sounds pretty nice, pretty nice. Yeah, I just received from your mother that the book for math learning is already being received to you, right?
Oh, math.
For the math book. So you already learned some of the lesson in the class. So the teacher already taught you something.
Yeah.
I see. Okay, so before we start, I just would like to check with you, you know, trying to understand. Uh, how is the lesson? Is there anything that you'd like to ask? For example, I believe that the first lesson was the integers, right? Is that easy for you or just like still confusing for you? Maybe I can help you to
Oh no.
not really.
Oh, not really.
Okay. Because
Saudara,
at the first moment, when I saw the book, right, I noticed that this was actually something that we already learned in different form. Remember on our previous lesson that we actually learned about the transformation grid, right? Placing certain objects above the Cartesian grid. There is X and Y. If you put it in bottom and the left, something like that.
Yeah.
Yeah, and there is on your lesson at school that there is actually -7, -6 as part of the example on what integers are. I think uh I'm 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 pretty certain that you actually have less difficulty in terms to understand the lesson, but I still would like to check up with you. That's why I ask. Okay, I think that was pretty straightforward for you to understand. Uh, can you tell me whether the lesson is already completed? Means that you already moved to the next unit, or it's still on the integers,
Um, I'm learning about algebra right now. The
algebra.
letters.
Okay, okay. So I think I think for the next meeting, for the next class on the Thursday, I'm gonna try to combine uh the algebra lesson. So let's try to catch up with the current lesson that you actually have. So in case that you actually already learned that lesson, just consider that our lesson from time to time would probably talk about kind of refreshment in order for you to really understand the concept. But in case that you have certain requests, in case you would like to tell your mother that mother, I didn't really understand about this lesson, those lessons that I previously learned at school, but unfortunately it already passed, and Mas Iqbal trying to teach me something that is really similar to the school, just let me know. I'm gonna try to accumulate all the materials and I'm gonna teach you about that. Sounds pretty cool for you?
Yeah.
Okay, cool. For tonight, we are still going to focus first on what we have left on the last lesson. I believe we already learned about the area, right? And trying to put on hold for the lesson as we this one as we try to understand why there are like two different kind of shapes that we need to understand the sections. And we already concluded that for the triangle that are actually randomly being drawn, right? It's sometimes a bit tricky to understand, to calculate or to measure the base itself, right? That's why there is a certain line being drawn right here, just to identify, just to to let you know that for this kind of triangle, the base measurement would be like this from this edge to another edge. It would be considered as a similar base. But if the only information that you got for this kind of triangle, if the base is only being drawn, being marked like this, means that the rest of this triangle is still unknown. So that's why you need to remeasure, recalculate what's the base for the other half of that triangle in order for you to perfect the calculation to measure the area. Um, why is this important? Because getting to the more complex things where we could actually have like combine shapes into one exercises, or maybe you see a complex building which involving a lot of shapes, uh to have kind of the diligence to really take a look whether you have all the information you need before calculating it is somewhat important. Like for the others, like this one. Okay, I'm gonna try to put kind of refreshment for you to understand, just to make sure. Can you help me to identify three of these? Which one you would like to pick first?
The rectangle.
Okay, the rectangle. You have the length and the width already. I think there's none to find, right? So what's the area for this rectangle?
6
Hmm?
6 meters.
60.
6
60?
meters.
Okay,
Because 5 times 12 is 60.
meters. 60 square meter. Because there are 2 meters right here. And since we are trying to using the multiplication, the same measurement unit will be added twice. I'm sorry, will be multiplied twice. That's why we try to get used to it. For every area measurement, the same measurement unit, once it gets multiplied, like meters multiplied by meters, and other measurement unit like liters multiplied by liters, it would be square liters, and for this case is square meter. In case your teacher would have like kind of a verbal exercise for every student, right? You are right putting on the calculation for 12 multiplied by 5, but don't forget to also put the measurement unit, especially for shape, right? It should be the square meters. Okay, good job. For the triangle, ah, we already know the base for the random triangle. The total base is 8 and the height is 5. So what do you think the area with this?
For, I think for the right side, it's, it's 5 times 3 or 2, I think. I think, um, I think 3. No,
Three.
yeah, times 3.
Okay. So how much would that be?
15.
15. Okay. Do you want to relook at that? Maybe you would like to be certain about your calculation, or is it locked?
Um, Wait. I don't know how like to calculate the underside, like when there's 8 and then when the line is not in the middle, I don't know how to find the base again.
Okay. Let me try to help you with that. Since we already seen there is another line being drawn at the bottom of this triangle, right? And this line was drawn exactly from edge to edge to the another edge. So meaning the numbers right here, 8 meters, is already included to as a whole base of that triangle. So we can change this from 3 into 8 since we are going to measure the whole area inside of this triangle. Ah, but there is kind of distraction when you also see the kind of vertical line being pulled from the top to the bottom right. That's why sometimes most of the people see there are two kinds of triangle that we need to measure. But since the baseline being drawn at the bottom is being drawn from the edge to the another edge, right? So we actually just conclude that it is actually for the same triangle. The base is already included to the same triangle. It also applies the same to the triangle. Sorry, to the height of the triangle itself. When there is a line being drawn vertically from this triangle, so we just conclude this is actually the height of that triangle, whether it's about the second or the first triangle, right? Because eventually, if we split this triangle into two parts, right, they are the first and the second triangle, the height will be the same, right? Now, and then for the triangle, it's there is like additional formula that we need to add is that we need to divide them by two, or it can be simplified by saying that sorry, half of the base and also the height of the triangle. Both using this and that would give you the same answer. This half factorial numbers is actually quite important for the triangle to measure the area of the triangle. So if you were using this formula to calculate the area of the triangle, so how much the area of this?
So 5 times 8 is 40 and
Mhm.
divided by 2 is, I think it's 20
Correct. It would be 20, 20 centimeters, kilometers.
meter square.
Square meter. Correct.
Yes, square.
Okay. If you notice that the area of the rectangle is actually bigger than the area of the triangle itself. But what if I change this triangle to be 10, sorry, 10 meters as well, 6 meters for the height. So how much the area of this triangle?
Um, 10 times 6 and then it becomes 60 and then divide by 2 becomes 30.
Correct. If we change this to be 10 meters as the base and height for the 6, we got 30. So from what you already calculated, right? The conclusion is even if we try to put same length for different shape, it doesn't mean that it will give you the result of the same amount of area. It also applies with the perimeter, I believe, right? The same length, the same height, the same base will not give you the same answer because the shape is different. But sometimes, if also the length of the side also different, it doesn't mean that actually it will give you the different results. Sometimes it's just like the matter of the calculation. You don't have to really worry about it. Okay, good. I consider that you already understand that. Uh, let's try to continue for the parallelogram. It's really hard to pronounce. My tongue is really twisted when trying to pronounce that parallelogram. It's similar to jajar genjang in Indonesia. Parallelogram or jajar genjang, it's actually kind of a combination, a shape that is actually be part of the combination when you try to slice a rectangle like this diagonally, but not exactly at the corner, right? When you try to slice this kind of rectangle, and then you add, and then you add a triangle from the left side of that triangle, you could actually define this kind of shape. It is pretty common for the parallelogram as another kind of form of the rectangle itself. And the kind of formula that we try to use is actually similar to the rectangle itself. Just that what we call on the rectangle is we know already that there's length and there's width, right? But for the parallelogram, we actually consider the horizontal base as a base, and the vertical one is the height itself. Uh, so the kind of what we call on the way we put into the calculation is a bit similar with the triangle, like the previous one that we learned already, but actually calculating the area of this kind of shape is actually similar to the rectangle. It's a bit twisted, I know. So we, whenever we have this kind of shape, we don't have to add half. Even if I already explained to you that there is kind of like a triangle that was being added to the other side of the rectangle, we don't have to add half into our calculation of that area. We just simply calculate the base with the height itself. So back to uh the one that you already calculated, like previously you hadn't yet added the half factorial into this formula, right? It was just purely about the base and the height. It was actually something that we use to calculate the area for this kind of shape. That's why we just have to put 10 multiplied by 4. So the answer should be 40 square meters. Ah, do you understand?
Um, yeah.
Ah, that's the kind of tricky part when you're trying to uh calculate the area for this shape. Just that you need to understand how to memorize them all. Triangle, they should be halving. Rectangle, you only have to know the width and the length. For the triangle, you just have to use the halving. for every calculation. But the basic formula for the area, they will always use multiplication. They will always use multiplication. Instead, perimeter would always use addition. Okay. For triangle, since that we already memorized that the triangle should be halving, right? The area of the triangle should be half or 1 of 2 factorial of the base and the height itself. If you only take this element without the halving, this is the formula of the area of parallelogram. Similar kind of thing that we need to know. We need to know the base, we need to know the height, just that when we add a halving fact as part of our calculation, means that we're trying to measure the triangle. But if we pull out the half itself, it means just we try to calculate the area of the parallelogram. Okay, so it's different shape, right? So it's a bit tricky when you just forgot about the way to calculate it. It means that you are actually calculating for another shape. That's the kind I hope that you don't do that. Okay. Now, I'm gonna try to put this as example. As part of the example, from what you see here, we have the unique case where we have similar numbers just being put on the different condition. For the parallelogram, the 4 meters right here is actually being defined as the height, but the base is 10 meters. The height is 4 meters. Meanwhile, on the rectangle, the width and the length is actually same, right? From this perspective, the height itself is actually similar to the rectangle, right? Because it's just like a simple vertical line. Am I correct? Ah, and also the base is also something that we call the horizontal line. Okay, but eventually they use the same formula 10 multiplied by 4. It for the rectangle, it's also 10 multiplied by 4. Okay, so whenever you see the parallelogram, just remember, okay, how to calculate the area of this uh parallelogram. Okay, the formula would still be the same as the rectangle. Just the way that we try to define each side of this shape is a bit different. 4 meters in rectangle is the width. 4 meters in the parallelogram is actually being defined as height. Ah, meanwhile, for the rectangle, the 10 meters itself being defined as the length, but for the parallelogram, the 10 meters is being defined as the base. Formula will still be the same, but the characteristic of the shape is that the way we try to understand the shape. Okay, now what about we add a bit complexity the way that we try to calculate the area? So imagine that a ranger on the campsite actually tried to show you that there's actually a space uh, that was actually the combination of shapes, which is, for the example, I tried to put rectangle and square for the example. Ah, but we don't have any formula yet, right? We don't have any formula yet at this moment. We just know that there is like rectangle, square, triangle, and so on and so far. We already learned. But for this round, how do we actually calculate it? Uh, the first that I'd like to show you, it's actually something similar when we learned about the parameter. Remember when I tried to split all the combined shape just for calculating the parameter. Do you still remember that?
Yes.
Ah, Turns out, turns out the result would give you the different answer compared to the manual calculation that you used to, right? On the parameter, we try to just add every outer layer. For example, this one is 6, this one is 5, so and so far we just put them all into the calculation of addition and we find how much parameter of this shape, right? But when we try to pull each shape, trying to understand them, turns out the result was different, right? This is actually the correct one. When we try to split the combined shapes, it's for in the purpose of calculating the area. Why was that so? It's because remember the concept of the area is we are trying to calculate what's on the inside. Meanwhile, for the perimeter, we try to calculate what is on the outside. So it's totally different perspective. Ah, but for calculating what's on the inside, but we also face combined shape, right? We actually can split into different kind of shape. It's just for the example, whether you would like to have a different model, the way that you want to split it up, it would actually give you the same answer. Ah, but when I try to split, I try to assume that there would be only three shapes. Uh, but for this one, just ignore this. Just ignore this part. There would only be two shapes, which I predefined it as the shape A and the shape B. When I try to combine two shapes together, it would give me the L shape, right? After I split it up, I put all into calculation based on the area that I see. From what I split it, right? This one is 8. I'm sorry. I think it's a bit being cut into half. I don't know why. I thought that I put the cutting in inside of the shape, but the number here was also being cut. Okay. For this shape, I already have 8 meters as the length, and also for the width, I also have 3 meters. So I try to measure the area of first rectangle. Let's define this as the first one, and this is the second one. The second one, I also already defined them. I already defined them that this is 5, this is 3. This is width, not the length. This is length. So the length is something that is still horizontally being drawn as the line. But even if I don't know yet this one, can you tell me how can we find this 5?
Find the five. Like, what do you mean?
If let's say this is something that is still unknown, how do we find the answer to measure this with for the second shape?
Mm, I don't know.
Uh, okay, this is something that I'd like to show you. The reason why there is like kind of a square right here is just like the assumption. Okay, imagine there is no line right here. There is no line right here. Okay, what you got is only the L shape. First, I try to pull all the line way down to make this shape is full. Uh, Trying to put from another edge to the another edge and trying to see what shape it actually was, right? Like for the example, I try to draw another line on this one, and from the top, I think this is the edge. I try to also draw the line and try to connect with each other. So what shape is this? If I connect this
Rectangle. With square.
square, correct. Do you know the characteristic of the square? What is the characteristic?
It has like all the same sides.
It has all the same sides. Meaning, if it is not the L shape, but a square, means that what we got right here would be still the same 8 meters, right? Because initially we already know that the total length from this edge to the another edge is 8 meters. So can I say that this is actually a side if if we assume this is a square,
Yes.
right? Okay, 8 meters. And the second one, since let's pull them out again, let's just back to the reality that this is actually only an L shape. But I already know this edge to this one is actually 3 meters, right? But we already know from edge to edge, all the way down to the bottom, is 8 meters. So basically, the way that we try to find this 5 is as simple as 8, as in total, of that side that we imagine to have minus 3. Do you understand that?
No.
Ah, okay. So that's why this is 5 meters is concluded, right? It's also similar when we try to find this 3, right? When we try to find this 3, back again, we try to draw a line and we look from bit far and we saw a square and we already know that the characteristic of the square is actually they would have a similar side, right? So there is no way this is 8 meter, this is 6 meters. No, square is not something like that. So it is still 8 meters. 8 meters. But I already know this is 5. So this is 5 meters. If I try to find this out, I just simply 8 minus 5. Okay, good. That's the kind of interesting part when trying to find an unknown length of certain side. Okay, so let's back to put this as an L shape. The first area already being calculated. Remember, all area should be multiplication. Meanwhile, the perimeter is addition. For the A shape or the first shape is 8 multiplied by 3. Meanwhile, for this part is oh 3 multiplied by 5. 3 multiplied by 5 because I we already concluded this is 5. So it would be like 15. Ah, and then after that, we just put all together both areas into the addition to find the total area of that L shape. So 24 plus 15, what's the result? What do you think? 24 plus 15,
24 plus 15. Um, I think it's it, 40. Wait, I have to calculate.
let's try to draw it. Yeah, let's try to calculate in the paper. 24 plus 15, how much would that be?
Huh?
Yeah, let's try to write it down on the paper. 24 plus 15, how much?
39.
Right, 39. 39 square meters. Don't forget. Or we can write it down like this, square meter. So for the total area for this combined shape is actually 39 meters. Now, the next question. is, can we actually have a combination of shapes, but not rectangle only? Yes, it can be a lot. It can be like a parallelogram combined with the triangle, or maybe triangle combined with square, or maybe the circle, something like that. But the way that we actually try to calculate the area of that combined shape will still be the same. We just have to split them into whatever, how many shape that you would like to have, for as long as you have all the information. Uh, After you split them all, you can separately calculate the area of each shape that you already splitted. And after that, you just combine all together, whether you have three shapes, four shapes, two shapes, and so on and so forth. You would get the total area. That's the way that we have the total area. Ah, this is something I think I don't have to share with you. And also for the little can, I think this is something extensive. Okay, this is something extensive that you could personally learn by yourself. Remember when we tried to walk in the park in the park and we tried to rent a bike,
Yes.
there is something like pricing and something, right? Remember we tried to also calculate uh how much money that we could spend if let's say we try to afford this and that. Okay, for this actually it's a bit similar where we try to uh, paint the game hall, the wall, something like that. And each of the paint that we need, there is there are two kind of prices. The first is like the 1 liter can of paint and also 5 liter can of paint. Both of them for sure has different in terms of pricing, right? In case there's kind of a complexity, I believe you already understand that. The way that we try to rent a bike when we have multiple needs, we try to combine each other. We also have the answer of how much money that we could spend. It's similar to if we already measured a compound area like this one, and then we already identify how many square meters that we need to cover, and then we try to decide which can that we need to afford, right? From there, we find how many budget that we need to allocate to paint the cam hall. That's actually the same thing. Okay, I think we already learned four shapes within 2 sessions. We already learned about the way to measure the area of the rectangle and square, triangle, and right now we already learned about the parallelogram and also the compound shape. Okay, before I end the session, let's try to calculate this. Can you help me with that?
Um, wait. So,
I forgot to put this one. Let's try to put it as like 2 meters. So how much the total area?
wait, I don't know how, but like, I want to guess by logic. So, I think like
Okay.
first,
Hmm?
what you call it, you pisahin like the both
Okay.
shapes, and then
Hmm.
so the first shape is 2 times 10 is equal to 20, and then
Horizon is 20. Okay, cool, cool.
three three times. I don't know like the language.
Okay. You
Oh
don't
wait,
know the language.
eight,
Ah,
eight,
8. Because of why?
because of the one.
Because of the one. There are
So,
two one right here
yeah,
on left and the right, right? Even though I didn't write anything right here, you could actually simply like, okay, seeing this is quite similar to the other side. This is 1 meters. Good job to identify that. So it would be 8
yeah,
centimeter.
8 times 3, 8 times 3 is 20. Wait. I don't remember. Is it 24?
Correct.
So, and
What's the
then
measurement unit for this one? For these two?
per square meter.
Correct. Square meters.
Then you add both of them, I think.
Correct. Once
Becomes
we got
44.
them, we just simply add them into the addition as part of the combined shape is 44, right?
Yes.
44 square meters. Okay, good job. I think you are that easy to understand that. So what's about this one? Another one. Let's try them. Okay. And then I'm gonna try. Sorry if my drawing is really bad. I'm not using the uh, actual pencil. Okay, so from these two combined shapes, this is 4 meters and this is 3 meters. You only have only two information right here. So what's the total area for the shape? For your information, this part is actually a square, yeah, not a rectangle. But I intended to draw a square. I just don't have the ruler to draw it exactly.
So the square is all 3, so 3 times 3 is 6, so the square is 6.
3 times 3 is 6. Are you sure?
Oh, 9, 9, 9, 9.
9. Okay. 3 times 3 is 9 meters, square meters. And then,
And
what
then
about the rest?
the triangle, mm,
One key element in triangle. What's that?
um, side, side.
One key element in triangle, there is always a halving.
Yeah.
I already give you a clue for that. So what's the area of the triangle?
Um, yeah.
Half of
So for 3 times 4, I think 3 times 4 is 12. So, and then divide by 2, it becomes 6, I think.
6. You sure about that?
No.
Okay. Since that I already confirmed to you that the second shape is actually square, means that all the side would be 3 meters, and at the same time, the edge of the square itself is already being connected with the triangle. So we can conclude from the way that we see that the base of the triangle is actually the side of the square itself. Ah, are you seeing what I see? So the base of this rectangle is actually the side of that square because it's being connected exactly, right? So that's why, since the unique characteristic of a square is actually they have a similar side, so this would be 3 meters. At the same time, we already identified this is actually the base as well because it's being connected with a triangle. That's why we put 3 as well 4 since the height of the triangle is 4, right? We only use this 3 meters since it's being connected with the other shape. Meanwhile, for the height, since it's really independent, not being connected with this one, right? That's why we put different height. That's why it's okay to put 4. Ah, as for the triangle, the area of it would be the halving of the height multiple by the base itself. We have 3 multiplied by 4, and then we cut it into 2 or divided by 2. We got 6. If so, what's the total area for this combined shape?
6 plus 9 is 15.
Okay, good job. I think you already understand that. Just a bit tricky part I'd like to remind you that remember whenever you are missing some of the information, especially for calculating this kind of combined area, doesn't mean that the information is actually not available, but it just requires you to really take a look at it. Remember, for each shape that I already taught you about, try to remember all the characteristic. If it is square, means that whenever you try to measure all the side of the square, would give you the same result, right? So even if you don't know yet about this kind of length, you actually just have to put one characteristic of the square itself. You would figure out what's the base of that triangle since it's being connected. That's what I want to remind you of, right? So even if that we don't have all the information, it doesn't mean that we actually don't have that kind of information. So you don't have to force yourself when you see 4 meters and 3 meters in a combined shape. And then when you are being asked to calculate the area of this combined shape, you just simply put it like 3 multiplied by 4. Not only is not reasonable, but it's also a false calculation to begin with, right? We already recognize this is the combined shape, right? Ah, Even if there is no exact line right here, you could actually independently trying to put a dot line right here just to help you to understand this is actually a combined shape. So you don't have to force yourself to calculate the whole shape at once. Ah, okay, that's the kind of thing I think would be kind of lesson for us to take away tonight. Okay, I think that would be it. Is there any question for you to ask? Oh, sorry, I just realized that.
No.
Ah, okay. So, what's the hardest part for you to understand? Is that the parallelogram, since it's a bit like kind of rectangle, but not? Or maybe the combined shape itself?
I think it's like the triangle, because like some triangles doesn't have like the same length or width, and like we have to like find out first and then calculate. So I think that's the hardest.
I see, I see. I think, I think for the triangle, it's also a bit tricky for me as well. But to me, the triangle part, right? For as long as you actually try to connect it with the understanding the characteristic of the triangle itself, you could actually, can find out the rest of the information. For example, for sure, the triangle must have the height and the base. How do I find the base itself? Okay, if let's say that I draw a triangle right here, uh, sorry if it crossed the line, so it would not be the edge to edge, uh, but I already know that the length of a rectangle itself is 10 centimeters. So how much the base of this triangle? Can you help me to find out?
Um,
No? Okay.
wait. I still remember. I think the one helps it.
This one?
Yeah, like I think
This
so.
one is one. Okay.
Of
And
that,
then
no, that one. So I think it becomes 19. I think because it's 20. So the base is 19. I think.
20 right here is actually the area of the rectangle. If the length if the length of the triangle is 10, and we already know the rest of this, if we draw a dot line, this is actually being connected, right? So this is 1 centimeter. Meanwhile, full line of the length of the rectangle is 10. So we just have to put 10 minus 1. That's why the answer would be 9 centimeters, right? Why? We use the minus, uh, minus kind of thing, because if there is no triangle, the length of this rectangle would still be the same, right? 9 centimeter plus 1 centimeter. It would be 10 centimeter, right? But since there's a triangle right here, the way that we try to calculate the base, first we already know the information about this, and this triangle, the edge of the triangle is actually, we can draw a dot line and see that, oh, this is actually connected. So this is 1 centimeters, and then it means the base of the triangle itself would be the rest. That's the kind of the way we try to measure things. But if the triangle also have the height, it's really rare for us in this kind of this exercise to actually find ourselves the height of the triangle itself. So initially, the height of the triangle is something that we know already, whatever the numbers. But most of the tricky parts for the combined shape, especially, it's the way that uh each side of the shape it's actually being connected. So it's really hard for us to identify that. Okay, I agree with that. Okay, is there any other thing that still confusing for you?
No.
No. Okay. So that's for the area, the way that we try to identify it all. I hope that even if that there are some shapes that I haven't yet touched, like the circle, what's the area, and then I don't know how to say in English. I forgot about it. Trapezium in Indonesia. I forgot the way to say that in English. And other shapes. I hope that you could understand the basic concept of area and perimeter. Area should be multiplication. Meanwhile, the perimeter would be the addition itself. When it comes to the combined shape, then we use the addition as part to calculate the total, right? Since we are talking about the total, that's why we are using the addition as part of our calculation to measure the total area of all sides that being used to combine to each other. That's the kind of thing, as well as the characteristic of each shape that we already know. It's kind of important to understand the shape before we are trying to touch any kind of numbers, because if we didn't understand about the characteristic of each shape, most likely we will take a different numbers that most likely it's not the right numbers that are going to be calculated. Okay, so that's the last thing before I end this session. For the next session, I think we will be going through for the algebra. I'm going to take a look deeper for that. And yeah, thank you so much for having a good session for me tonight. Bye, Widdy. Have a good night.